guys, so the next topic, and it will be the last topic for this lecture, because I know you have to do a lot of digestions in here of the material, will be 9.10. And the topic, the title of the topic is the mole and chemical calculations. Chemical calculations. Now, so again, all you have to do now, find the conversion factors here. And all you have to do now with the conversion factors, follow the given desired model to get your final answers. So what kind of problems could be presented in this section here? Well, let's check them out. I'm gonna go straight into the, I guess, problem number example 9.11 and see how I can handle it. So the problem 9.11 here example is on page 353. There is a following problem. Nicotine, the second most widely used central nervous system stimulant in our society, caffeine is first, occurs naturally in tobacco leaves. It is chemical formula, and that's what I want to get right now. I want to get this chemical formula here. C10H14N2, C10H14N2, that's your formula for nicotine. And the question is, how many nicotine molecules are present in 0.0015 grams? You got so many nicotine grams, and always what I like to do is I want to figure it out, what's the question, what are they asking me to do? And of course I'm going to go back to the problem and it tells me how many nicotine molecules are present. So I know what I need now. I need units of molecules of nicotine, which is C10H14. For some reason I'm going to N for oxygen, but there's no oxygen here. Now, okay. So how do we handle this now? Well, remember the mole, 1 mole of a substance, in this particular case, nicotine here, is Avogadro's number, of course, 10 to the positive 23 molecules of nicotine, which is again C10H14N2. That's one conversion factor for the mole, right? And the second conversion factor for the mole, we talked about it already in the previous discussion, is what's the molar mass now of this 1 mole? And to do that, you need to go to the periodic table and just look up the molar mass for this element, for this element, for this element. Don't forget to multiply by 10 this element, 14 this, 2 this, and then add them all up. So let's do it real quick. So I got now 10 moles of carbon equals to 10 times 12.01 grams, whatever it is. I got 14 moles of hydrogen, and that will be 14 times 1.008 grams. I got 2 moles of nitrogen, and that will be 2 times 14.01 grams. All I have to do now is real quick calculations. This gives me 120.1 grams. This gives me here, I don't want to be killing my brain today. I have enough headache today, so I'm going to use a calculator. So that will be 14.11 grams, 112. And this one is, of course, 28.02 grams. Remember, guys, very important, is that when we calculate the molar mass, we always go by the precision. You're going to have to imagine that you take 12.01 10 times and add them all up. So you're going to go by the what's called precision rule. And so this one is in the 100 place. So when I do the molar mass for the substance, molar mass, I have to round it off everything to the 100 place, because that's the least precise, I guess, number here in this digit and this digit. This digit is rounded off to the thousands place, so it's more precise. So remember, the rules are I have to choose I have to truncate my final answer here to the least precise number, which is in this particular case the 100th place. Okay, so let me do it real quick. So that will be 120.1 plus 14.112 plus 28.02, and so I got now here 162.23 grams, and that will be molar mass of my nicotine C10H14 and 2. Okay, so now I got my conversion factor here, my more, and it's one more conversion factor is 162.23 grams of C10H14N2. Okay, so now guys, I'm equipped with two conversion factors, as I discussed before, and so this problem now becomes an easy one because I can now use one conversion factor at a time to get to the units that I want to get. So of course I'm going to do the first step is to match the units. I have the grams here of this substance, and I'm looking for the conversion factor that's the grams. Oh, there it is. So I'm going to use this conversion factor first. I'm going to line down moles to cancel, and to 162.23 grams of this substance. Cancel, canceled. See, if I do it this way, remember how we make a mistake. So that would be incorrect. See, I did it on purpose to see if you guys are still with me. So that will be incorrect because I cannot cancel the moles with the grams. Therefore, this is wrong. So what I have to do now is I have to switch, I have to flip this and make it the correct way so I can cancel the units I don't want. So 162 here will go in the bottom, of course, C10H14 and 2, cancel, cancel. Now I can cancel same units. That's important, guys. And then one mole, of course, will go on top, C10H14 and 2. And so I'm almost there. But you see, my unit's still not matching. But with one more conversion factor, I can get there. And now I'm going to use this one I already used up. I'm not going to use it, so I'm going to go now to this one. And I want to cancel moles, so I'm going to line up these moles to cancel, of course, as we've done before, unit analysis. So that will be my Avogadro's number right on top. 23 molecules now of C10H14N2. And so look at this, I have my match. Therefore, that means I set up everything correctly. All I have to do is just a little mathematics, 0.0015 divided by 162.23, and then multiplied by Avogadro's number. I'm pretty much got my home run in here, not only in terms of units, but also I believe I got the right number here. The only thing that's left is to put down the number with the correct number of significant figures, positive 18, and that should be the final answer. So what I just did is that they asked me in 0.015 grams of this particular molecule, how many molecules it contains. So typically you probably will conduct an experiment to answer this question, but since we know the conversion with the moles, that's what makes our life easier now, to go from something that is given to us in the form of powder, without even doing any experiment, we can figure out how many molecules were got in the so many grams of that particular substance.